Hello everyone and welcome to my YouTube channel. Today we will be continuing with our new lecture 2. So in this lecture what we will be doing, we will explore USD, Universal Scene Description, and how to create a stage and put some cube using Omniverse API. So today we will be continuing with lecture 2.py and lecture 2.md files, and we will try to create our first object using Isaac Omniverse, and we'll see it in UsdGeom. Okay, so welcome to this lecture and let's start. So let me tell you about USD. So USD is a universal scene description. So it's a format that you can, using it, explain your robot, explain any object and define it. So maybe you are familiar with STL files and this kind of files. So STL also define robots joints, their shapes, like square, circle, mesh, cones, whatever, and this universal scene description is some similar language, and UsdGeom is using it, and it's by Pixar. And if you want me to show some of it, let me see what we have here. Okay, so now I have an extension, so it shows, this will be with the output of our lecture, by the way, this cube. So for now, let me open with text editor. So you see it's saying like USDA, and here you have a world and you have a box, and the size of this box is 2. So this is the definition of this box. Okay, so the box is a cube object, the world is something called xform, and everything, maybe we can call it the stage. So let's go and start our tutorial, and we'll see, and we'll try together to research and do some trials together. Okay, so let's start. So as we did at the lecture 1, first we have to import the simulation app from UsdGeom, then we have to define our kit, and I'm using false so I can show you the UI. And we are importing some libraries, OSTime and the USD libraries from Omniverse API, and the USD and USD geometry from Pixar libraries. Then we are getting the output path. So now we will create some stage and this cube using the Omniverse API, and we will use this output path, and it is this one, to generate this USDA file and save it. Okay, so let's go. So what is a stage? Okay, so the stage, you can think about it about our environment. So everything we have is the stage. So we can define it like this. A stage is what you actually program against. Right now it's backed by exactly one layer, the file at output path. So this file is your whole stage. I mean, the file will be generated, yes? I showed you before 1 minute. Stage and layer look like the same thing until lecture 4. So I will not tell you the difference between stage and layer until lecture 4. We will discuss it there. But for now you can understand that stage is everything you have, everything you program. We are composing several layers together in the entire point. So maybe you can think like we have layers and we can compose them into one stage and this kind of stuff. Okay, for now. So it's worth knowing from the start that there are two different objects that happen to be one here. So what we have to do at first, we have to create a stage. So to create a stage, we are using USD from Pixar library, and we're doing USD stage, create new, and if you press it, like you see there is a method like create a memory, create new, click plus prim, and you can try them or research for them if you're worried what you can do, and this will create our stage. Okay, let's read this together. A prim is the named node in the stages hierarchy. Think a form in a file system tree. Define a prim creates one. X form is a USD's transform holding grouping type. Must seen have word, so is the root one. So this word, you can think it about like it's your root. So you have everything in this world, and this one is like your reference, your global reference, and it's something like standard, like most things have it already, and you can see it here. Open with text editor. Yes, you see it's X form cubed the size. So we can define it, this prim, and it will define world. So this is a path. Yes, I don't know why this doesn't click, and X form is the type, and it is USD's transform holding grouping type. So this is defining the main and the root of our application. Then to create a cube, so we have some API under USD geometry. So here you can define a cube and give it a path also. So we say it's under wall, and it will be named box. Okay, and here we can give it some size. So under USD geometry cube, let me go, and yes, like you have here the methods of the cube, define, get extension, size attribute, and this kind of stuff. And here you can see like there is like a cone class. So maybe we can try to do some cone. Okay, we will give it a try. I didn't try it by the API, but we can try. I mean, you have to try to learn. Okay, so an attribute is a named type value living on a prim. So size above is one of this attribute, so it have an attribute, the box, and its size. And get attributes list every attribute the prim schema declares, whether or not a value was ever set for it. Is authored tells you which. So you can go for loop between all attributes in box get prim attributes. Okay, so you can look to all the attributes it have and see if it's authored, what attributes it is having. So like here, it will print something like this when we run it. You will see this one. So this is the attribute and the size. Okay, so what we write here, we get it here. So we can change this stuff and play with them. Okay, okay, and here we can find whatever is in script, and to do it we can use some method called traverse, and this like walking in the script. So this is returning all the prims, and you can it's listing for us, and you can go and doing a for and list them. So you can see like world is X form and world box is a cube, and this is a bat. Yes, and here you can save it. Yes, stage get root layer dot save. It save it to the root layer, and it saved it. And here after we save it, we just read it, and you see the file. It's the same. I showed you before. It's the same file. So if you want, we can change it. So this is our purpose, okay, to make this cube. So we define it. We can define the size. We can see this attribute and change. And let's go here. So I did some kind of coding to just visualize it and make sure we are seeing it. So let's read this stuff, okay? It will help you to understand. The stage objectable lives only in the Python process. It was never handled to the USD context, which is a thing that actually drives the viewport. So our object now is still in Python, and it's not given to the simulation, so we cannot see it. Yes, if you're running with headless fall, expecting to see a box appear, checking the viewports on stage right after USD stage create new finds it completely empty. So after you create it, if you check, you will find it empty, and this happens to me at the first time. Why? Let's see. Because this stage and the viewport stage are two different objects that happen to share nothing until you connect them. Open stage on the file, just save it in that connection. So yeah, our Python Pixar script is different than the UsdGeom one, okay? So we have to do some connection. So if you see to this line, we didn't use anything about Omniverse API. We was just writing some file format using Pixar library, okay? So now is the right time. Let me check if everything is going well. Yes. So what we are doing now, we are using OmniUSD get context, and we define our context. Okay, so this is our USD context, and after we save this file, now we can open it, and this is opening our file is the context. So now our USD file is loaded. Okay, then a quick render of the box just defined purely, so this lecture MD has something real to show rather than asking you to picture the cube prime from its attribute list. So camera mechanics are in lecture 7, and it's not normally included here, but I will just be going very fast, okay? So we will go into details about everything, okay? But just this is the minimum to just see the cube, yes, in Omniverse. So first we get the stage, yes, and this stage now is from the context that we will define using Omniverse API. You see it here, and it's the GUI stage now, okay? Then we put to USD using UsdGeom.Cube. So okay, so I want you to show something. So let me see. So we create some color attribute, and what we give it, okay, so we give it the box, okay, the path, and we create some color so we can see it, okay? So I hope, okay, so this is some color, okay? Maybe if I go, I can show you how to use it. Okay. Oh my god, this is empty. Okay, maybe we can just read this explanation, yeah? Because I don't remember. Let's try to ask AI, okay? And see, because we don't have to remember everything. I think it's some kind of RGB, but I forget. Maybe I have take some notes here. Okay. Oh my god. Forget to take note. Okay. Yes, so it's red, green, blue, and it's percent. Okay, so it's RGB. As I told you, but just not between 0 and 255, but just you know, some percentage, and it's the same, doesn't matter. Yes. So whatever, then you define some camera, you're using USD camera define, still the same stage and some preview, and so you translate the camera to be able to see this cube, you know, this translation like of just the camera and rotation of it, so it's like XYZ and raw pitch, something like this. I don't know if they don't have the explanations here, but that's it. I mean, so it's XYZ and it's raw pitch, and from UsdGeom sensors.camera we are importing the camera now. So this was still in the Pixar. Okay, so now we're importing the camera from UsdGeom sensors, because it's an UsdGeom future. Yes, the camera sensor. So we're getting it from sensors. We're getting our camera and we're initializing it, and as you see, we're giving it the same path. Okay, and we can give it a resolution and have a lot of things you can change from frequency, resolution, position, orientation, translation, and this kind of stuff. So maybe we can, I mean, maybe we don't have to do it here, maybe we can do it here and this kind of stuff, but just for consistency, so if we define it here, we don't have to change a lot later. So after we do the preview camera, we initialize it and we import Omni timeline. Timeline play RGB now, kit update for EN60. So yes, we are running this 60 times, this loop, and we are updating our kit, so we're making this working, and we are getting an RGBA image from our camera. Okay, and also here we can get the path, and we can save our camera picture. So I think, yeah, we can see it like this. Okay, I will show you it, and here we can hold you know hold our simulation for X seconds, so we can see it inside UsdGeom. So let me run it. So if we run it, I show you how to run it in the first lecture, but it's also written in the MD file. So you see, this is our cube, yes, in the simulation. Okay, so it's not holding very much, so let me do it. I mean, we're trying together, yes, we have to try something together. So let me see what's going on. It will be holding it for 100 seconds, should be enough to us to explore. So you see this is a world, everything is a world, and there's a box inside it, and the sun and the preview camera. Okay, so this is our box, and we can do it like this. You see, we transform it. So you see, this is X, and this is X, this is Y, and this is Z. And orientation is this. See, this is orientation. So it's row pitch should be, or maybe row pitch yaw, I'm not sure. And here is scale, so we can scale it also. I mean, we can change the definition of it a little bit. Okay. And if you press left of your mouse and A and D, you can go like this if you are using WASD and while pressing your mouse, or you can use the wheel of your mouse. Yes, this kind of stuff. And using the wheel of your mouse, you can make it more slow or more fast also while moving. So like this fast and this like slow, fast, slow. So you can play with your mouse, left click. Oh, sorry, right click, not left. Sorry, very sorry. It's right click. Okay, so I hope you get the idea. So let's try to change something. We need to play it. Let's try to write 10 and see what happens. Maybe it will not work, I'm not sure. Let's see. Let's see. Okay. What's going on? Oh, you see, we was inside the box. So now the box is very, very, very big. And we was inside the box. Okay, so this is it, our box. And we was some kind of inside it, and the box was like centered like this or something like this. Yes. Okay, because I'm holding it, I cannot exit. I will do some Ctrl C, it should be fine. So let me take it again to 2. Can I try something else than a cube? So do we have, I mean, maybe cone? Is this cone fine? Can we replace it with cone directly? Let me try. Let's see. So first we have it here. Maybe it will work directly. Cone, and this will be cone. I think I miss maybe something. Okay. This looks fine to me. Let's see. Oh, I should save this. Okay, I forget to do some Ctrl S, but let's see. I'm not sure if it will work now. Okay. Okay, this is still not working because press. Should be working this time. See? If not, let's debug it together. Okay. Oh, so okay. So cone doesn't have something called size. Probably it have another thing. So let me see. Okay, so create height attribute and radius attribute. Let me try height and radius. Yes, I mean it makes sense. It doesn't have something else. So let's me try create height. And from here, let's try create radius. attribute, and probably the radius should be, the height should be 2, the radius 1 should be enough, and it will make sense. Okay, so it makes sense. Maybe we have to translate this a bit. I mean, orientation. If I can put like, okay. Oh, okay, the wrong direction, I think. Huh. Okay, so it's a cone. Why it's like this? So probably there is some configuration. So this is, you know, that is nothing exactly circle, so it's a lot of points. So this depends on how you do it. So like here, there is some cones like with other things. It would be, like you see this cone. This is very rounded. Okay, this is very big, of course. But I just wanted to show you. So I will do Ctrl Z, and let's try to see why this is not routed. Let's see what we have as a features, what we can add. Okay, get, create extended attribution, height, radius, and extended attribution. Let's try this. What's doing? I mean, you have to explore this kind of stuff and see what's going on. Okay, so let's see what this is doing. Let's see. What? So let's take a look. Okay, so I'm not able to see something very clear change, but like, okay, so it's not clear to me the change, to be honest. Okay, let's see what we have now in our USD file at least. Okay, I will be looking to the other thing. Okay, so you see, like, we have height, radius 1, this kind of stuff. And if I press it like this, okay, here is very circular. I think it's maybe something caused by UsdGeom itself. So here there is no problem in the USD itself, or maybe because it's very small, you know. And this is about something called resolution and this kind of stuff. Can I change something here? Word. Okay, so box. Okay, so you see position, rotation, scale, children, bounce and mesh and material groups. Okay, anything else? Okay. Some kind of tools that you can use that help you. Okay, so this is kind of beautiful extension, and you can install this extension. It's called 3D Mesh Viewer from here, and it will help you very much in this kind of stuff. I mean, this is not an ad, of course, but I find it helpful. Yes. And how much minute we was recording? So yeah, now it's 29 minutes. But at least let us see what we can try out. Okay, so if we can try to make the height 20 and this will be 10. If it's bigger, is there any difference? Just let's see, I mean, what's going on. And we was looking to this extend attribution. Okay, sorry. Oh, so why this is not in English? English, please. So this function accepts two option parameters, default value and write separately. So the fallback access aligned bounding box values for the cone. It makes VT array containing. So the first vector defines the minimum corner and the maximum corner. Okay, this is some kind of helper, so it doesn't affect anything. Okay, so when we made it bigger, it's now like this. So why this is not very rounded, I really don't know. But I think it's related to some of the parameters. And maybe you can think it about like homework and why this is not working, okay? Also, you can ask AI for it. Why this is not working? I mean, why it's not ideal circle? So it's normal to not be ideal, but I mean why it's very low resolution, have very low resolution, okay? I don't think we have circle, so the other classes are capsule, camera, okay. So you can explore them here, I think. Cube, curve, cylinder, mesh, Xform, tokens, state mesh, and there's a lot of things you may explore. Like, let me see normally what you have in Isaac scene here from the menu. So normally, okay, so normally tools create. So normally you can create mesh as cone, cube, cylinder, this, or shape as cone, cube, cylinder, and you have lights, this kind of stuff, camera scope. So let's try like mesh cone. Okay, this is creating very big, I don't know why, and this. So this is mesh type and this is, so here the type is mesh, here the type is cone. So that's the difference between them. Maybe if we go, I mean it feels me. So you see the mesh one looks better here, I think. While the cone one still looks not very, you see, still the same as ours. So it's not a perfect circle, but the mesh one is more perfect. You see the mesh one, because I mean it's mesh and it's maybe it have a lot more of resolution. So that's it. I hope you enjoyed this tutorial and we will be continuing in the other tutorials. So what we have next, if you want, take a look, and please subscribe to our channel, by the way, to be able to see our new videos. So we will take a look to the transformations, to the compositions, references, flattening. Maybe we can go into our Redmi and see, yes? So we'll go to physics, simulation loop, cameras and rendering, lights, articulations, joint drives. Here we will be seeing the most simple way to drive a joint, and capstone. about everything. And here in model 2 we'll be going to sensing, mapping and mobile report, and I think you will enjoy it. Here we'll be working with 2D lidar, 3D lidar, camera parameters, mapping, path planning, this kind of stuff. And the 3 is the more interesting place, but I think also model 2 is very interesting. So we will have some 2D lidar and we will do some map, and we will explore our the objects using the lidar. And here we will have a depth camera. Okay, this is not completed yet. And here we will have some grid and how to generate path and finding the path using A star. And we'll see unit 3 H1. We'll try to run the unit 3 H1 policy and do some drive controllers and everything together. Okay, so I hope you enjoyed the tutorial, and please subscribe if you like it, and please let me know. And if you have something to discuss, please write to the comments and we will discuss it together. Thank you very much for watching, and see you later in the next videos. Have a good day.